Hello there, and welcome to the Dozing Explorer. I'm so glad you found your way here tonight. Take a moment now to settle in, to let the weight of the day begin to dissolve, feeling the surface beneath you holding you completely. There is nothing you need to do, nowhere you need to be, except right here, in this quiet space we have created. Tonight we're going to drift into the endless mysteries of the stars. We won't be studying them in a classroom sense, but rather we will wander through their silent, shimmering light. This is not a lesson but a gentle journey, a slow exploration of the vast and peaceful ocean of the cosmos. We will simply float on a current of quiet wonder, letting these facts about the stars become a gentle rhythm to guide you toward rest. We'll explore the silent song of the cosmos, a lullaby written in light that has been traveling for eons just to reach us. We'll listen to the whispers of stellar nurseries where new suns are born and drift through the beautiful fading embers of stars that lived long ago. Each point of light in the sky is a story, a fireplace burning across an impossible distance. And tonight, we will simply warm ourselves by its ancient glow, feeling its peace without needing to understand its every detail. And just before we begin our drift, if these quiet explorations help you unwind, consider liking and subscribing. It's a small, silent gesture that helps other sleepy souls and wandering minds find their way to this little corner of the universe, too. It helps our community of dozing explorers grow, and for that, I am truly grateful. But for now, that is all in the distance. There's nothing you need to do. Your only task is to breathe. Settle in, breathe deeply and softly, and let the journey begin. Your mind is free to wander, to drift, and to dream. Let my voice be a gentle anchor in the quiet darkness, and let the wonders of the stars guide you softly into sleep. Every star you see in the night sky is bigger and brighter than our own sun. It's a curious thought that our magnificent life-giving sun is, on a galactic scale, quite modest. The reason for this is a simple matter of perspective across immense distance. The stars we can see with our unaided eyes are the celestial giants, the lighthouses of the cosmos. They are so exceptionally luminous and so colossal in size that their light can successfully travel the unimaginable gulfs of space to reach us. The countless smaller, dimmer stars, like the common red dwarfs, are like tiny bonfires on a distant shore. Their gentle light simply isn't strong enough to complete the journey to our eyes. So the canopy of night is a curated gallery of only the most brilliant specimens. The night sky is a tapestry woven only with the most brilliant threads. When you look at the stars, you are looking into the past. Light, though it is the fastest thing in the universe, does not travel instantaneously. It has a finite speed, moving at about 186,000 miles per second. Because the stars are so profoundly far away, the light that reaches your eyes tonight left its star long, long ago. For the nearest star, Proxima Centauri, that journey is a little over 4 years. For other stars, like those in the Orion constellation, the light has been traveling for hundreds or even thousands of years. So when you gaze upwards, you are not seeing the stars as they are now, but as they were when that light began its long, lonely voyage. It is a form of time travel, a glimpse into a history written in photons. The night sky is a museum of ancient light. The twinkling of a star is an illusion created by our own atmosphere. Out in the vacuum of space, starlight is a steady, unwavering stream of light. Stars shine with a constant, peaceful glow. The familiar twinkle we see is a phenomenon that happens only in the final fraction of a second of the light's long journey. As the starlight enters Earth's atmosphere, it passes through pockets of air that are constantly moving and are at different temperatures and densities. These pockets act like gentle, shifting lenses, bending the light this way and that. To our eyes on the ground, this constant, subtle bending makes the star appear to shimmer and dance. It is the Earth's own breath making the distant suns twinkle. There are more stars in the universe than there are grains of sand on all the beaches of Earth. This is one of those statements that is difficult for the human mind to truly hold. Try to imagine standing on a beach, feeling the countless grains of sand beneath your feet. Now imagine every beach on every continent, every coastline, every island. The sheer number is overwhelming, yet astronomers estimate that for every single one of those grains of sand, there are perhaps 10,000 stars out there in the observable universe. Our galaxy, the Milky Way, contains a few 100 billion stars alone, and there are hundreds of billions, perhaps trillions of other galaxies. It is a number so vast that it becomes a feeling of profound awe. The universe does not count its suns, it simply lets them shine. The color of a star tells you its temperature. Just like a piece of metal heated in a forge, a star's color is a direct indicator of how hot its surface is. The coolest stars, which are still incredibly hot by our standards, glow with a soft, gentle red light. Warmer stars, like our own sun, appear yellowish-white. The very hottest and most massive stars in the universe burn with a brilliant, intense blue-white light. So when you look up at the night sky and see the reddish tint of a star like Betelgeuse and the stark blue-white of a star like Rigel, you are seeing a celestial temperature gauge painted across the cosmos. Their colors are a silent whisper of the immense fire within. A star does not truly have a surface, but a gradually thinning atmosphere. We often think of stars as solid balls of fire, but they are something far more ethereal. A star is a sphere of intensely hot gas and plasma held together by its own immense gravity. There is no solid ground to stand on. If you were to travel towards a star like our sun, you wouldn't crash into a surface. Instead, you would simply find the gas getting denser and denser and hotter as you moved closer to the core. The surface we see, called the photosphere, is simply the layer from which most of the light is emitted. It is less of a surface and more of a visible boundary, a place where the star becomes opaque. A star is a cloud of fire bound by gravity's gentle hold. The light from some stars has been traveling for millions of years to reach your eyes. While many of the stars we see are hundreds or thousands of light years away, some visible objects are much farther still. When you look towards the Andromeda Galaxy, the closest major galaxy to our own, it appears as a faint, fuzzy patch of light to the naked eye on a very clear night. That faint glow is not a single star, but the combined light of 1 trillion stars. And that light has been traveling through the void between galaxies for 2.5 million years to finally reach you. When that light began its journey, modern humans did not yet exist on Earth. It is a humbling and peaceful thought to be touched by something so ancient. You are catching photons that are older than human history. Our sun is actually a green-blue star, but our eyes perceive it as yellow. This seems counterintuitive, as we have always known the sun as a golden yellow orb. The sun's light is not one single color, but a spectrum of all colors, like a rainbow. It actually peaks, meaning it emits most of its light in the green-blue part of the spectrum. However, when this light passes through Earth's atmosphere, the shorter wavelength colors like blue and violet are scattered more easily by the air molecules. This is why our sky is blue. By the time the sunlight reaches our eyes, enough of the blue light has been scattered away that the remaining colors combine to look yellowish-white to us. The sun's true color is filtered by the very air that gives us life. Stars are almost perfect spheres, more round than any planet. You might think that planets, with their solid surfaces, would be smoother and more spherical. But a star's immense gravity is a powerful, perfecting force. Gravity pulls equally in all directions from the center, pulling the star's gaseous material into the most efficient shape possible, a nearly perfect sphere. Planets, on the other hand, rotate much faster relative to their size, which causes them to bulge out at their equators. Our own Earth is slightly flattened in this way. A star like our Sun rotates so slowly compared to its massive size that this bulging effect is incredibly minimal. It is a sphere of fire shaped by the perfect symmetry of gravity. The nearest star to us, besides the Sun, is over 4 light-years away. Its name is Proxima Centauri, a small red dwarf star that is part of the Alpha Centauri system. To say it is 4 light-years away is an easy phrase, but the distance it represents is staggering. A light-year is the distance light travels in 1 year, which is nearly 6 trillion miles. So Proxima Centauri is about 25 trillion miles away. If you were in the fastest spacecraft ever built by humans, it would still take you tens of thousands of years to reach it. This vast, empty space between the stars is what defines the cosmos. It's a universe composed mostly of a quiet, deep, and peaceful emptiness. Each star is a distant island in an ocean of silent darkness. Stars spend about 90% of their lives in a stable, shining phase. This long, peaceful period of a star's life is called the main sequence. During this time, the star is in a state of perfect equilibrium. The immense inward crush of its own gravity is perfectly balanced by the outward pressure from the nuclear fusion happening in its core. For a star like our Sun, this stable phase lasts for about 10 billion years. It is a testament to the beautiful balance of the forces of nature. The star is not struggling. It is simply existing in a state of cosmic harmony, converting hydrogen into helium and releasing the energy that makes it shine. It is the long, quiet adulthood of a star. A star's light is created by the fusion of atoms in its core. In the heart of a star, the pressure and temperature are so extreme that something incredible happens. Hydrogen atoms, the simplest and most abundant element in the universe, are squeezed together with such force that they merge or fuse to become helium atoms. This process, called nuclear fusion, releases a tiny amount of energy, but a star does this billions upon billions of times every second. All of this released energy pushes outward, providing the pressure that supports the star and eventually making its way to the surface to be radiated out as heat and light. It is the same process that powers a hydrogen bomb, but in a star, it is controlled, stable, and sustained for billions of years. Every ray of sunlight is born from this cosmic alchemy. If you could travel at the speed of light, you would still need years to reach the next star. It is the ultimate speed limit of the universe, and yet, even at this speed, the cosmos remains vast. Imagine setting off on a journey at 186,000 miles per second. You would pass the moon in just over a second. You would reach Mars in a few minutes. But to reach Proxima Centauri, our nearest stellar neighbor, you would have to travel continuously for 4.2 years. To reach a bright star like Sirius, it would take over 8 years. To cross our entire Milky Way galaxy, it would take 100,000 years. The universe is built on a scale that transcends our concept of speed and travel. The distances between stars ensure a profound and lasting peace. Some stars are so faint they can only be seen with the most powerful telescopes. The stars we see with our eyes are just the tip of the cosmic iceberg. For every star visible to the naked eye, there are millions that are not. The vast majority of stars in our galaxy are small, cool, and dim red dwarfs. They are like cosmic embers, glowing gently for trillions of years, but their light is too weak to be seen across interstellar distances without aid. It is a quiet reminder that the most common things in the universe are not always the most obvious. The sky is filled with a hidden, silent multitude of unseen suns. The sun makes up over 99% of the mass in our solar system. It is difficult to overstate the dominance of the sun. If you were to take everything in our solar system, all the planets, From Jupiter to Mercury, all the asteroids, all the comets, all the moons, and put them on one side of a scale and the Sun on the other, the scale would barely tilt. All of planetary existence as we know it is just the leftover material, the tiny fraction of cosmic dust and gas that wasn't swept up into forming our star. The Sun is the gravitational anchor, the engine, and the great heart of our system. Everything else simply dances to its tune. All the planets are just motes of dust in a sunbeam. The most common type of star in the galaxy is a small, cool star called a red dwarf. While our minds are drawn to the brilliant blue giants and our own yellow sun, the universe has a clear preference for the small and subtle. Roughly 3/4 of all stars in the Milky Way are red dwarfs. These stars are much smaller than our sun, sometimes only a fraction of its mass, and they burn their fuel much more slowly. They glow with a dim reddish light, like the embers of a cosmic fire that never goes out. Their commonness is a quiet truth of the cosmos. The universe favors the gentle and the enduring over the bright and the fleeting. The galaxy is a quiet kingdom ruled by humble stars. Red dwarf stars can live for trillions of years, far longer than the current age of the universe. Because red dwarfs are so small and sip their hydrogen fuel so slowly, their lifespans are almost incomprehensibly long. Our sun will live for about 10 billion years. A red dwarf can live for 10 trillion years or more. The universe itself is only about 13.8 billion years old, which means that not a single red dwarf star that has ever formed has reached the end of its life yet. Every single one is still in its stellar infancy. They are the great survivors of the cosmos, destined to glow gently long after all the brightest stars have faded away. They are the final, quiet embers of the universe. The largest known star, Scuti, is so vast it could contain our Sun 5 billion times over. This is a star of truly monstrous proportions. It is a red hypergiant, and its size beggars belief. If you were to replace our Sun with Scuti, its surface would extend out past the orbit of Jupiter, and perhaps even as far as Saturn. The Earth and all the inner planets would be comfortably inside it. It is not the most massive star, however. It is incredibly puffed up and diffuse like a colossal glowing cloud. Its existence shows the incredible range of forms that stars can take, from tiny, dense dwarfs to these impossibly bloated giants. It is a star the size of a solar system. Blue giant stars are incredibly hot and bright, but they live very short lives. These are the rock stars of the cosmos. They are massive, sometimes over 100 times the mass of our Sun, and they burn through their fuel at a furious rate. This intense energy output makes them shine with a brilliant blue-white light and makes them among the most luminous objects in the galaxy. But this extravagant lifestyle comes at a cost. While a star like our Sun lives for 10 billion years, a blue giant might live for only a few million years. They are born, shine with unimaginable brilliance, and then die in spectacular supernova explosions. They are the beautiful, fleeting fireworks of the galaxy. There are stars known as pulsars that spin hundreds of times per second. When a massive star collapses, its core can be compressed into a tiny, incredibly dense object called a neutron star. As it collapses, its rate of spin increases dramatically, just like an ice skater pulling in their arms. Some of these neutron stars are born spinning at fantastic speeds. A pulsar is a neutron star that has a strong magnetic field and beams of radiation shooting out from its poles. As the star spins, these beams sweep across space like a lighthouse. If one of these beams happens to sweep across Earth, our radio telescopes detect a regular, repeating pulse. Some spin so fast they would complete hundreds of rotations in the time it takes you to blink. They are the universe's most perfect cosmic spinners. A pulsar flashes a beam of light towards us with the regularity of a perfect celestial clock. The precision of some pulsars is truly astounding. Their rotational periods are so stable that they are more accurate than the best atomic clocks we have ever built on Earth. Astronomers can use the timing of these pulses to study the space between stars, to test Einstein's theories of relativity, and even to search for gravitational waves. This dead, spinning stellar core becomes one of the most useful tools we have for understanding the cosmos. Its rhythm is a heartbeat that resonates across the galaxy, a steady and reliable pulse in the vast silence. It is a clockwork remnant of a star's violent death. Neutron stars are the collapsed cores of massive stars, and they are unimaginably dense. After a supernova explosion, the core of the star can collapse under its own gravity. The pull is so strong that it overcomes the forces that keep atoms apart. Protons and electrons are crushed together to form neutrons, packing them into a space only about as wide as a city. The material of a neutron star is the densest form of matter known in the universe, aside from what might be inside a black hole. It is so dense that all of humanity could be compressed to fit into a space the size of a sugar cube. They are stellar ghosts crushed by their own weight into something almost impossibly small. Some stars are locked in a silent waltz with a partner, orbiting each other for eternity. Our Sun is a solitary star, but it seems that this is not the norm. At least half of all the stars in the galaxy are part of binary or multiple star systems. These are stars that were born together from the same cloud of gas and are gravitationally bound to each other. They orbit a common center of mass, locked in a graceful, silent dance that can last for billions of years. Sometimes they are far apart, taking thousands of years to complete one orbit. Other times they are so close that their atmospheres touch and material flows from one star to the other. They are lifelong companions in the cosmic darkness. These binary star systems are incredibly common throughout the galaxy. The image of a single lonely sun is perhaps more the exception than the rule. From our perspective on Earth, these systems often look like a single point of light, and it is only through careful observation with telescopes that we can see they are actually two or more stars. The universe, it seems, prefers companionship. This has profound implications for the search for life, as planets in such systems would have complex orbits and might experience the light of two suns in their skies. The galaxy is filled with pairs of stars quietly circling one another through the ages. Brown dwarfs are often called failed stars because they never became hot enough to ignite. In the process of star formation, sometimes a clump of gas is not quite massive enough. Gravity squeezes it, and it heats up, glowing with a dim, magenta-colored light from its own warmth. But it lacks the critical mass, about 80 times the mass of Jupiter, needed to start nuclear fusion in its core, so it never truly becomes a star. It simply cools slowly over billions of years, fading into the darkness. They occupy a fascinating, hazy middle ground between the largest planets and the smallest stars. They are the gentle, quiet, almost stars of the universe. A magnetar is a type of neutron star with a magnetic field 1,000 trillion times stronger than Earth's. This is a force so powerful it defies easy comparison. A magnetar's magnetic field is the strongest known in the universe. It is so intense that it could wipe a credit card's data from a distance of 100,000 miles. If a magnetar were as close as the Moon, its magnetic field would rip the atoms in our bodies apart. These objects occasionally have starquakes on their crusts, which cause them to erupt with colossal flares of gamma rays and X-rays. They are the most powerful magnetic objects in all of creation. White dwarf stars are the cooling, glowing embers of stars like our Sun. After a star like our Sun has exhausted its nuclear fuel, it doesn't explode. Instead, it gently sheds its outer layers to form a beautiful planetary nebula. The hot, dense core that is left behind is a white dwarf. It is an object about the size of the Earth, but with the mass of the Sun. It no longer generates heat through fusion. It is simply a cosmic ember, slowly radiating away its leftover heat over billions and billions of years until it eventually fades into a cold, dark, black dwarf. It is the long, peaceful retirement of a star. There may be a white dwarf star whose core has crystallized into a diamond the size of a planet. As a white dwarf cools over eons, the immense pressure inside it is thought to cause the carbon and oxygen it is made of to crystallize, just as carbon on Earth can crystallize into diamond. Scientists believe that some very old white dwarfs may have cores that are essentially gigantic diamonds. One such star has been nicknamed Lucy after the Beatles song. It is a mind-boggling thought, a diamond weighing trillions of carats, floating silently in space. It is the universe's ultimate jewel, hidden in the fading light of a dead star. Variable stars are stars that rhythmically brighten and dim over time. Not all stars shine with a constant light. Some, known as variable stars, have a natural pulsation. They are physically expanding and contracting, like a slowly beating heart. As they expand, they cool and become dimmer. As they contract, they heat up and become brighter. Some of these stars have incredibly regular periods, brightening and dimming over a precise number of days or weeks. This reliable rhythm allows astronomers to use them as cosmic measuring sticks to determine distances to other galaxies. They are the breathing stars of the cosmos. Hypervelocity stars are stars that are moving fast enough to escape the gravity of our galaxy. Occasionally, a binary star system may wander too close to the supermassive black hole at the center of the Milky Way. The immense gravity of the black hole can capture one of the stars, while flinging the other one out into intergalactic space at incredible speed, millions of miles per hour. These hypervelocity stars are destined to leave our galaxy forever, becoming lonely wanderers in the great dark void between the galaxies. They are exiles from their home on a one-way journey into the unknown. Stars are born from colossal, cold clouds of dust and gas, called nebulae. If you look at images from deep space telescopes, you often see beautiful, colorful, swirling clouds. These are nebulae, the stellar nurseries of the universe. Within these vast, cold clouds, which are hundreds of light years across, gravity begins its slow, patient work. It gently pulls the sparse dust and hydrogen gas into denser and denser clumps. These clouds are the raw material of creation, holding the potential for millions of new suns and new worlds within their beautiful, ethereal wisps. A star's first home is a cold, dark, and beautiful cloud. These stellar nurseries are some of the most beautiful objects in the cosmos. The colors we see in photographs of nebulae are often the result of different gases being energized by the light of young, hot stars that have already formed within the cloud. Hydrogen typically glows red, oxygen glows blue-green, and sulfur glows orange. The result is a breathtaking celestial painting, a masterpiece of cosmic art sculpted by gravity and light. Each nebula is a unique sculpture, a temporary monument to the process of creation that fills the void with light. They are the great, silent workshops of the universe. Gravity slowly gathers clumps of this dust and gas into a warm, spinning ball. Inside a nebula, it is not a uniform process. Some regions are slightly denser than others. These denser regions have a slightly stronger gravitational pull, and they begin to attract more and more material from their surroundings. As the clump grows, its gravity increases and it pulls in even more gas and dust. This process is like a slow, gentle cosmic snowball effect. As the material falls inward, the clump begins to spin and the pressure at its core begins to build, causing it to heat up. It is the slow gathering breath before a star is born. Before a star ignites, this gathering ball is called a protostar. A protostar is a stellar infant. It is hot and glowing, but not from nuclear fusion. It glows because of the heat generated by the immense pressure of gravity as it continues to accrete more and more matter. A protostar is typically surrounded by a thick disk of dust and gas, from which planets may eventually form. It is in a delicate stage, still gathering mass, on the very cusp of becoming a true star. It is a period of quiet growth, hidden deep within its dusty cocoon, waiting for the moment its heart will ignite. A protostar is the promise of a sun. The death of a star can be a quiet fading or a spectacular explosion. A star's final moments depend entirely on its mass. A lower mass star, like our sun, will have a very gentle end. It will swell into a red giant, shed its outer layers as a planetary nebula, and leave behind a cooling white dwarf. It is a slow, graceful dissolution. A star with more than about 8 times the mass of our sun, however, will have a violent and spectacular death. It will explode as a supernova, an event of unimaginable power that can forge new elements and trigger the formation of new stars. The universe allows for both a whisper and a bang at the end of a life. Our sun will one day swell into a red giant, engulfing the inner planets. In about 5 billion years, the sun will have used up the hydrogen fuel in its core. Its core will contract and heat up, which will cause its outer layers to expand dramatically. The sun will grow so large that it will swallow Mercury, Venus, and possibly even Earth. It will become a red giant, cooler on its surface but hundreds of times larger than it is today. It will be the final grand phase of our star's life, a last great expansion before it peacefully fades away. It is a future so distant it becomes a peaceful, abstract thought. When a truly massive star dies, it explodes in an event called a supernova. The end for a high-mass star is far more dramatic. When it runs out of fuel, its core collapses in a fraction of a second. This catastrophic collapse triggers a powerful rebound shockwave that blasts the star's outer layers out into space at incredible speeds. This explosion is a supernova. It is one of the most energetic events in the universe. The energy released in a few seconds can be more than our sun will produce in its entire 10 billion year lifetime. It is the universe's most spectacular firework display. For a few weeks, a single supernova can outshine its entire galaxy. The light from a supernova explosion is so intensely brilliant that it can temporarily outshine the combined light of the hundreds of billions of other stars in its host galaxy. If a star were to go supernova in our own galaxy, it could be bright enough to be seen during the day and cast shadows at night. It is a final, defiant blaze of glory, a beacon that announces the death of a giant to the rest of the universe. Its light is a final, brilliant farewell. The death of a massive star can leave behind a black hole. If the core of the star that collapses is particularly massive, more than about 3 times the mass of our sun, gravity will win the final battle. Nothing can stop its collapse. The core will continue to shrink until it becomes an object with gravity so strong that nothing, not even light, can escape its pull. It creates a region of space-time from which there is no return. This object is a black hole. It is not a monster, but simply a final, quiet testament to the ultimate power of gravity. It is a shadow left behind by a brilliant light. Black holes are not cosmic vacuum cleaners. They are just objects with immense gravity. There is a common misconception that black holes travel through space, sucking up everything in their path. In reality, a black hole's gravity is only powerful very close to it. If our sun were to magically be replaced by a black hole of the same mass, the Earth and the other planets would not be sucked in. They would continue to orbit it just as they do now, though in complete darkness and cold. You have to get very close to a black hole to be in danger of falling in. From a distance, its gravity behaves like any other object of the same mass. A planetary nebula is the gentle, expanding shell of gas, shed by a dying sun-like star. The name is a little misleading. They have nothing to do with planets. They were given this name centuries ago because their round, glowing shapes looked a bit like planets through early telescopes. When a star like our sun becomes a red giant, its outer layers become unstable and are gently puffed away into space. The hot core of the star, the new white dwarf, shines with ultraviolet light that ionizes this expanding gas, causing it to glow in beautiful, intricate patterns. It is the star's final gentle sigh into the cosmos. These nebulae look like glowing cosmic smoke rings in space. Because of the way the gas is shed and shaped by the dying star's magnetic fields and rotation, planetary nebulae can form breathtakingly complex and symmetrical shapes. We see shapes that look like hourglasses, butterflies, or concentric rings. They last for only a few tens of thousands of years, a very short time in cosmic terms, before the gas dissipates into the interstellar medium, enriching it with heavier elements. They are fleeting, ghostly memorials to the stars that created them. The process of star formation can take millions of years from start to finish. The universe operates on timescales that are far beyond our human experience. From the initial collapse of a region within a cold gas cloud to the ignition of a protostar, the process is incredibly slow and gentle. It is a gradual gathering, a slow compression, a patient waiting for the conditions to be just right. The birth of a star is not a violent event, but a long, slow, and peaceful accumulation guided by the persistent, gentle hand of gravity. It is a testament to the power of slow, steady processes over eons. Some stars are ejected from their galaxies and doomed to wander the void alone. We call them rogue stars or intergalactic stars. These stars are no longer gravitationally bound to any galaxy. They have been thrown out, often through gravitational interactions with other stars or with the supermassive black hole at a galaxy's center. They will spend the rest of their existence traveling through the vast, near-empty space between the galaxies. Their planets, if they have any, would have a night sky that is almost completely dark, with the faint, fuzzy glows of distant galaxies being the only light. They are the lonely sailors of the cosmic ocean. These are known as hypervelocity stars or rogue stars. The speeds at which they travel are truly incredible. A typical star in our galaxy orbits at a few hundred kilometers per second. A hypervelocity star can be moving at thousands of kilometers per second. They are moving so fast that the galaxy's gravity can no longer hold on to them. They are on an escape trajectory, a journey with no destination, a one-way trip into the profound darkness. They are cosmic castaways, moving in the great and silent emptiness. It takes light from the sun's surface about 8 minutes and 20 seconds to reach Earth. This means that if the sun were to suddenly vanish, we wouldn't know about it for over 8 minutes. For that short period of time, we would still see it in our sky and feel its warmth, oblivious to the fact that it was gone. It is a constant, subtle delay in our connection to our star. Every ray of sunshine we feel on our skin is a memory, a warmth that has already traveled 93 million miles to greet us. We are always living in the sun's very recent past. The energy at the sun's core was created thousands or even millions of years ago. The journey of a single photon of light from the sun's core to its surface is not a direct one. The core of the sun is incredibly dense. A photon created by fusion is immediately absorbed by a nearby atom, then re-emitted in a random direction. It is absorbed and re-emitted again and again, taking a long, staggering, random walk through the sun's interior. This process can take a remarkably long time, with estimates ranging from 10,000 to several million years. So the light that warms your face today was born in the sun's heart long before the dawn of human civilization. It is truly ancient energy. The sun has a powerful magnetic field that creates sunspots. The sun is a churning ball of electrically charged gas, or plasma. This motion generates a complex and powerful magnetic field. In some places, this magnetic field becomes so concentrated that it pokes through the sun's surface. These intense magnetic fields inhibit the flow of hot gas from the sun's interior, creating areas that are cooler than their surroundings. These cooler areas appear darker against the bright backdrop of the sun's surface. These are what we call sunspots. They are islands of magnetic calm in a sea of fire. Sunspots are cooler, darker patches on the sun's surface. While they appear dark, they are still incredibly hot, thousands of degrees Celsius. They only seem dark by comparison to the even hotter plasma around them. Sunspots are often larger than the entire planet Earth, and they can last for days or even weeks. They are visual indicators of the sun's magnetic activity, and their number and location change over time in a regular cycle. They are temporary freckles on the face of our star. The sun rotates, but it spins faster at its equator than at its poles. Because the sun is not a solid body, different parts of it can rotate at different speeds. This is called differential rotation. At its equator, the sun completes a rotation in about 25 Earth days. Near its poles, it takes more than 30 days to complete a rotation. This twisting, shearing motion of the sun's gas is what is believed to drive its magnetic field and the entire cycle of solar activity. It is a complex fluid dance that powers our star's dynamic nature. Our sun experiences a solar cycle that lasts approximately 11 years. The sun's magnetic activity, including the number of sunspots, solar flares and coronal mass ejections, ebbs and flows over a regular period of about 11 years. At the beginning of a cycle, the solar minimum, there are very few sunspots. Activity gradually increases to a solar maximum, where sunspots are abundant, before declining again. During this cycle, the sun's entire magnetic field flips with its north and south magnetic poles swapping places. It is the slow, deep breath of our star. A solar flare is a sudden, intense burst of energy from the sun's surface. Near sunspots, where the magnetic fields are complex and twisted, they can sometimes suddenly snap and reconfigure themselves into a simpler shape. This process releases a tremendous amount of energy in the form of radiation known as a solar flare. It is like a magnetic rubber band snapping. The energy from a single large flare can be equivalent to billions of hydrogen bombs exploding at once. They are powerful, sudden flashes from our otherwise steady star. The sun produces a constant stream of particles called the solar wind. The sun's outer atmosphere, the corona, is so hot, millions of degrees, that the sun's gravity cannot hold on to it completely. A steady stream of charged particles, mostly electrons and protons, is constantly flowing outwards from the sun in all directions. This is the solar wind. It travels at hundreds of kilometers per second, flowing past all the planets in the solar system. It creates a vast bubble of influence around our sun, called the heliosphere. It is the sun's breath, extending far into the cosmos. Earth's magnetic field protects us from this solar wind. Our planet has a molten iron core that generates a protective magnetic field extending far out into space. This magnetosphere acts as a shield, deflecting most of the charged particles of the solar wind around our planet. Without this shield, the solar wind would strip away our atmosphere over time, making life on Earth impossible. It is a silent, invisible guardian that keeps our world safe from our own star's constant stream. Our planet's heart protects its fragile skin. The beautiful auroras are created when solar wind particles interact with our atmosphere. Some particles from the solar wind are trapped by Earth's magnetic field and funneled down towards the magnetic poles. As these energetic particles collide with atoms and molecules of oxygen and nitrogen in our upper atmosphere, they excite them. As the atoms and molecules return to their normal state, they release this extra energy as light, creating the beautiful, shimmering curtains of the aurora borealis and aurora australis. It is the visible evidence of our planet's shield at work. The auroras are the masterpieces painted by the solar wind. The sun is about halfway through its 10 billion-year lifespan. Our sun formed about 4.6 billion years ago, and it has enough hydrogen fuel in its core to continue shining steadily for another 5 billion years or so. It is in its stable middle-aged phase. This incredible stability has been crucial for the development of life on Earth. We exist in a long, peaceful summer in our star's life, a period of calm and reliability that has allowed complexity to flourish. We are bathed in the light of a star in its gentle prime. The Sun is so large that 1 million Earths could fit inside it. It is the true giant of our neighborhood. Its diameter is about 109 times that of Earth. Its mass is over 300,000 times that of Earth. It is a scale that is almost impossible to visualize. If the Earth were the size of a small pebble, the Sun would be a glowing sphere more than 5 feet across. This immense size is what gives it the gravitational dominance to hold all the planets in their orbits. Our world is a tiny speck circling a colossal furnace. The Sun is traveling through the Milky Way at over 500,000 miles per hour. While we feel stationary, our entire solar system is on an immense journey. The Sun, along with all its planets, is orbiting the center of the Milky Way galaxy. Our speed is about 220 kilometers per second. Even at this incredible speed, the galaxy is so vast that one full orbit takes an incredibly long time. Our solar system is a tiny ship, silently sailing through the vast spiral arms of our galactic home. Even at that speed, it takes the Sun over 200 million years to orbit the galaxy once. This period of time is sometimes called a cosmic year. Since the Sun formed, it has only completed this orbit about 20 times. The last time our solar system was in its current position in the galaxy, dinosaurs were just beginning to roam the Earth. It is a slow, majestic, and silent journey that our planet has been on since its birth. The galaxy turns at a pace that makes geological time seem fleeting. The Sun has no solid surface to stand on. Like all stars, the Sun is a ball of gas and plasma. The visible surface we see, the photosphere, is just a layer of gas that is thin enough for light to escape from. If you were to try and land on the Sun, you would simply sink into hotter and denser layers of gas. There is no firmament, no ground, only an ocean of incandescent plasma that deepens into an unimaginable core. It is a world made entirely of fire and light. Constellations are patterns of stars that are not actually close to each other in space. For millennia, humans have looked up at the sky and connected the dots between stars to form patterns, creating images of animals, heroes, and mythical beasts. But these patterns are an illusion of perspective. The stars that form a constellation like Orion or the Big Dipper are not neighbors in space. They are often separated by vast distances, hundreds of light years apart, and just happen to lie in the same direction from our viewpoint on Earth. They are chance alignments across a three-dimensional universe. The stars in a constellation might be separated by vast distances. Take the Big Dipper, for example. One of the stars in its handle, Alkeid, is about 100 light-years away. Another star in the bowl, Megrez, is about 80 light-years away. The star at the end of the bowl, Dubhe, is over 120 light-years away. They appear to be a flat pattern on the celestial sphere, but in reality they are scattered through space at very different depths. If you were to travel to a different star system, all the constellations we know would change shape or disappear entirely. Our constellations are a uniquely terrestrial work of art. The patterns we see are a trick of perspective from our vantage point on Earth. Imagine looking at a forest from a distance. Several trees might line up to form a particular shape. But if you were to walk into the forest, you would see that the trees are separated by large distances, and their alignment was just a coincidence of where you were standing. The same is true for the stars. The constellations are the result of our specific location in the galaxy. They are a map that is only true from our home. There are 88 officially recognized constellations. The International Astronomical Union has divided the entire celestial sphere into 88 official constellations with precise boundaries. This means that every star in the sky belongs to one of these constellations. This system allows astronomers all over the world to have a common map and easily specify the location of any object they are studying. It is a way of imposing a gentle human order on the beautiful chaos of the night sky. Some constellations are only visible from the northern hemisphere, and others only from the southern. Because the Earth is a sphere, an observer in the northern hemisphere sees a different part of the sky than an observer in the southern hemisphere. Constellations like Ursa Major, which contains the Big Dipper, and Cassiopeia are prominent in the northern sky, but invisible from the far south. Similarly, constellations like Crux, the Southern Cross, and Centaurus are hallmarks of the southern sky, unseen by those in the north. The Earth's own shape divides the celestial storybook into two different volumes. As the Earth orbits the Sun, the constellations we see at night slowly change with the season. The side of the Earth that is dark, our night side, is always facing away from the Sun. As the Earth travels along its year-long orbit, the direction that our night side faces into deep space slowly changes. This is why constellations like Orion are prominent in the winter sky, while constellations like Scorpius are visible in the summer. It is a slow, seasonal parade of stellar patterns, a celestial calendar that marks the passing of our year. The North Star, Polaris, has been used by travelers for centuries to find their way. For anyone in the Northern Hemisphere, Polaris has a special property. It appears to remain almost perfectly stationary in the sky throughout the night, while all the other stars seem to rotate around it. This is because Polaris is located almost directly above the Earth's North Pole. By finding Polaris, you can always find the direction of true north. It has been a constant, reliable guide for sailors and wanderers for countless generations. It is the steadfast anchor of the northern sky. Polaris appears to stand still because it is located almost directly above the Earth's North Pole. Imagine the Earth as a spinning top. The point on the ceiling directly above the top's axis of rotation would appear to be still, while the rest of the ceiling would seem to spin. Polaris is in that special position relative to Earth's spin. This is a temporary alignment, however. Due to a slow wobble in the Earth's axis called precession, over thousands of years, the North Pole will point to different stars. In ancient Egypt, the pole star was a different star named Thuban. Our North Star is a privilege of our current epoch. Ancient cultures all over the world created their own stories and myths for the constellations. The patterns in the stars were a universal canvas for human imagination. The Greeks saw their gods and heroes. The ancient Chinese saw a celestial bureaucracy of palaces and officials. The Egyptians saw their deities sailing across the sky. Indigenous cultures in Australia saw the emu in the dark lanes of the Milky Way, not in the stars themselves. These stories were ways of making sense of the cosmos, of connecting the human world to the silent, eternal world above. The sky was humanity's first storybook. Many of the star names we use today, like Sirius and Vega, are ancient Arabic names. During the Golden Age of Islam, scholars in the Middle East made tremendous advances in astronomy. They meticulously observed the stars, preserving and building upon the knowledge of the ancient Greeks. They gave names to many of the brightest stars, and these names, like Aldebaran, Betelgeuse, and Rigel, were passed down through the centuries and are still used by astronomers worldwide today. It is a beautiful linguistic link to the long history of human curiosity about the night sky. An asterism is a popular pattern of stars that isn't an official constellation, like the Big Dipper. While the Big Dipper is one of the most recognizable patterns in the sky, it is not a constellation itself. It is an asterism, which is a smaller, more obvious pattern within a larger constellation. The Big Dipper is part of the official constellation Ursa Major, the Great Bear. Other famous asterisms include the Summer Triangle, formed by the bright stars Vega, Deneb, and Altair, and the Teapot in Sagittarius. They are the familiar, friendly nicknames of the night sky. The light from the stars in the Big Dipper ranges from 60 to over 100 light-years away. This further highlights the illusion of the constellations. Even within this simple, familiar shape, the stars are at vastly different distances from us. The light from Mizar, a star in the Handle, takes about 86 years to reach us. The light from Alkaid at the end of the Handle takes over 100 years. We see them as a flat pattern, but they are scattered through a deep volume of space. They are a family of strangers, brought together only by our line of sight. The Milky Way appears as a faint, cloudy band across the night sky. On a clear, moonless night far from city lights, you can see a hazy, luminous ribbon stretching across the sky. This is the Milky Way. For centuries, its true nature was a mystery. Ancient Greeks thought it was a stream of milk, while other cultures saw it as a celestial river. It was Galileo who first turned his telescope to it and discovered that this cloudy band was not a cloud at all. It was the combined light of countless individual stars, too faint and far away to be seen separately. That band is actually the light of billions of distant stars in our own galaxy's disk. Our solar system is located within a large, flat, spiral galaxy that we call the Milky Way. When we look towards that hazy band in the sky, we are looking into the densest part of our galaxy's disk, towards its bright center. We are seeing our own galaxy from the inside. The darkness between the stars in that band is not empty space, but vast clouds of interstellar dust that block the light from the even more numerous stars beyond. We are looking at the spine of our own galactic home. The best way to see the stars is far away from the light of cities. In modern times, many of us live under a sky that is washed out by artificial light pollution. This light scatters in the atmosphere and creates a constant glow that obscures all but the brightest stars and planets. To truly experience the breathtaking beauty of the night sky, with the Milky Way arching overhead and thousands of stars visible, one must travel to a remote, dark location. It is there that the true scale and peace of the universe reveals itself. The darkness allows the ancient light to be seen. Almost every element on Earth heavier than hydrogen and helium was created inside a star. The universe was born with only the lightest elements, primarily hydrogen, some helium, and trace amounts of lithium. Every other element on the periodic table, every element that makes up our world and our bodies, had to be created. This creation process happens in the intense heat and pressure of star cores. Stars are the cosmic forges where simple hydrogen is cooked into the heavier elements like carbon, oxygen, nitrogen, and iron. The universe is a grand recycling plant, and stars are its factories. The calcium in your bones was forged in the heart of a star. Think about the very structure of your body. The calcium that gives your bones their strength, the potassium that helps your nerves fire. These elements did not exist at the beginning of time. They were created through nuclear fusion inside generations of massive stars that lived and died long before our sun was ever born. When these stars exploded as supernovae, they scattered these newly forged elements across the galaxy, enriching the clouds of gas and dust from which new stars and planets would eventually form. Your skeleton is made of ancient starlight. The iron in your blood was created during the explosive death of a massive star. The process of fusion in a star's core can create elements up to iron. But creating elements heavier than iron requires an incredible amount of energy. It actually consumes energy rather than releasing it. This energy is only available in the final cataclysmic moments of a massive star's life, the supernova explosion. The iron in the hemoglobin of your blood, which carries oxygen to your cells, was created in one of these unimaginably violent and creative events billions of years ago. You carry the memory of a stellar explosion within every breath. Every gold ring on Earth was likely created during the collision of two neutron stars. Even a supernova is not energetic enough to create the heaviest elements in the universe, like gold, platinum, and uranium. For a long time, their origin was a mystery. It is now believed that these elements are forged in an even more extreme event, the kilonova, a cataclysmic merger of two super-dense neutron stars. The collision is so violent that it creates and flings these precious heavy elements out into the cosmos. The rarity and value we place on gold is a reflection of its incredibly rare and violent cosmic origin. You are, in a very real sense, made of stardust. This is not just poetry. It is a literal scientific fact. The collection of atoms that currently makes up your body was assembled in the hearts of stars that have long since turned to dust. You are a temporary arrangement of ancient matter, a piece of the universe that has become self-aware. The cosmos is not something separate from you out there in the distance. You are a part of it, and it is a part of you. The universe is experiencing itself through your senses. The carbon that forms the basis of all life was synthesized inside stars. Carbon is a uniquely versatile element, able to form the long, complex chains of molecules necessary for life as we know it. But this essential building block of life was not present at the universe's birth. It was created in the cores of stars like our Sun and larger ones through a delicate process called the triple alpha process, where 3 helium nuclei fuse together. Life on Earth is fundamentally dependent on this stellar alchemy that happened billions of years ago. We are carbon-based life, which means we are fundamentally star-based life. Stars are the great element factories of the universe. Without stars, the universe would be a very simple and uninteresting place, composed almost entirely of hydrogen and helium gas. Stars are the engines of cosmic complexity. Through their long lives and sometimes violent deaths, they create the raw materials necessary for rocky planets, for atmospheres, for water, and for life itself. They are the givers of all the interesting chemistry in the cosmos. The entire periodic table is a testament to the life and death of the stars. The water you drink is made of hydrogen created at the dawn of time and oxygen forged in a star. The hydrogen atoms in every molecule of water, H2O, are primordial. They are about 13.8 billion years old, formed in the Big Bang itself. The oxygen atom, however, was created much later, fused from lighter elements inside a massive star. So every time you drink a glass of water, you are consuming a substance that connects you to both the very beginning of the universe and the life cycle of the stars. It is a humble and profound cosmic cocktail. Our sun's gravity holds our entire solar system together in a delicate dance. While we are made from the remnants of other stars, it is our own sun's presence that gives us our home. Its immense gravity dictates the orbits of all the planets, keeping Earth at just the right distance for liquid water to exist and for life to thrive. It is a constant, gentle and invisible force that provides the stability and structure for our entire planetary system. We are held in a safe and predictable embrace by our star. The predictable light of stars has guided life on Earth for billions of years. Before humans, countless species used the light of the sun, moon, and stars for navigation. Migrating birds, nocturnal insects, and even seals are known to use celestial cues to find their way. The constant and predictable patterns of the sky have been a reliable map for life on this planet for eons. The stars have always been silent guides for travelers on Earth. Stars are not just distant lights, they are our cosmic ancestors. When we look up at the night sky, we are in a sense looking at our own extended family tree. We are connected by a direct, physical lineage to the stars that lived and died before our sun was born. This is a profound and comforting thought. It dissolves the feeling of separation between ourselves and the universe. We are not just observers of the cosmos, we are a direct result of it. The stars are our ancient, glittering heritage. The universe is constantly recycling material from old stars into new ones. The elements scattered by a supernova or a planetary nebula do not just drift forever. They mix with the vast interstellar clouds of gas and dust. Over millions of years, gravity will pull this enriched material together to form a new generation of stars and planets. Our own solar system is thought to be the result of several such cycles. We are made from second-hand or even third-hand star stuff. It is the great, slow, cosmic cycle of death and rebirth. There are stars in the Milky Way that are older than the galaxy itself. This sounds like a paradox, but it is a fascinating glimpse into how galaxies form. It is believed that large galaxies, like our Milky Way, grew over time by merging with and absorbing smaller dwarf galaxies. Some of the ancient stars from these consumed galaxies can still be found in our galaxy's halo today. They are immigrants from galaxies that no longer exist, celestial fossils that tell the story of our own galaxy's long and dynamic history. They are the quiet elders of our galactic city. Some stars have planets orbiting them, just like our Sun. For centuries, we could only wonder if other stars had their own worlds. In recent decades, we have confirmed the existence of thousands of these exoplanets. We have found giant planets orbiting close to their stars, rocky worlds in habitable zones, and even entire solar systems very different from our own. It seems that planets are a common, natural outcome of star formation. The galaxy is likely filled with trillions of unseen worlds, each one silently circling its own distant sun. A habitable zone is the gentle region around a star where liquid water could exist. Also known as the Goldilocks zone, this is the orbital distance from a star where conditions are not too hot and not too cold for liquid water to potentially exist on a planet's surface. For a hot, bright star, this zone is far out. For a cool, dim star, it is much closer in. The search for Earth-like planets often focuses on finding rocky worlds within this temperate, life-friendly region. It is the oasis of warmth and possibility around a stellar fire. Some stars are so massive that their gravity bends the path of light from behind them. Albert Einstein's theory of general relativity predicted that massive objects could warp the fabric of space-time. This means that the path of a light ray can be bent as it passes by a massive star or galaxy. This effect, called gravitational lensing, can be observed. Sometimes it can distort the image of a distant galaxy into arcs or even multiple images. The star acts like a giant natural telescope, allowing us to see things that are even farther away. Gravity itself can become a lens. The sound of the sun is a low, constant hum, though sound cannot travel through space to reach us. Sound waves need a medium to travel through, so the vacuum of space is silent. But if you could be close to the sun, protected from its heat and radiation, you would hear a deafening roar. Scientists have used data from solar observatories to translate the sun's surface oscillations into sound. The result is a deep, low-frequency hum, the result of millions of convection cells of hot gas rising and falling on its surface. It is the sound of a star's heart beating. Astronomers can study the sound waves inside a star to learn about its interior. Just as geologists use seismic waves from earthquakes to study the Earth's interior, astronomers can use the oscillations on a star's surface to understand what is happening deep inside. These oscillations are essentially sound waves reverberating through the star. This field is called astroseismology. By studying the subtle changes in a star's brightness, scientists can map out its internal structure, its rotation, and its age. They are listening to the silent music of the stars. This field of study is called astroseismology, or the study of starquakes. The surface of a star like our Sun is constantly churning with waves and ripples. These are caused by the pressure waves, or sound waves, that are trapped inside the star and bounce from one side to the other. By analyzing the frequencies of these waves, scientists can deduce incredible details about the star's hidden core, just as listening to a bell can tell you about its size and what it's made of. It allows us to see into the heart of a star using only its light. A standard candle is a type of star with a known brightness used to measure cosmic distances. Measuring distance in space is incredibly difficult. One of the most important tools astronomers have is the standard candle. This is an astronomical object that has a known intrinsic luminosity. Certain types of variable stars and supernovae behave in this predictable way. By measuring how bright one of these objects appears to us, and knowing how bright it actually is, astronomers can calculate its distance with great accuracy. They are the lighthouses that illuminate the scale of the cosmos. The oldest star we have ever found is nicknamed the Methuselah star. Officially known as HD 14283, this star is one of the oldest known objects in the universe. Its age is estimated to be around 14.5 billion years, which initially seemed to be older than the universe itself. However, the uncertainties in both measurements mean they are consistent with each other. This star is a true relic of the early universe, made almost entirely of hydrogen and helium. It is a living fossil from the dawn of cosmic time. Stars sometimes pass relatively close to each other without colliding. The space between stars is so vast that direct collisions are exceptionally rare. However, near misses can happen. A few million years ago, a star called Schultz's star passed through the outer edges of our solar system's Oort cloud. It is currently moving away from us. Another star, Gliese 710, is predicted to pass much closer in about 1 million years. These events are a reminder that the galaxy is a dynamic place, and nothing is ever truly static. The stars are all on their own slow, silent journeys. A stellar wind is a flow of gas ejected from the upper atmosphere of a star. Just like our sun has a solar wind, most stars have a stellar wind. For massive, hot blue giants, this wind is incredibly powerful and can blow away a significant fraction of the star's mass over its lifetime. For smaller, cooler stars like our sun, the wind is much more gentle. These winds shape the interstellar medium around them, creating vast bubbles of hot gas and influencing where the next generation of stars will form. It is the star's invisible breath shaping the space around it. Betelgeuse is a red, supergiant star that is visibly pulsating and nearing the end of its life. Betelgeuse, the bright reddish star in the shoulder of the Orion constellation, is one of the most fascinating stars in our night sky. It is a massive star that has swelled up to an enormous size. It is unstable, visibly brightening and dimming over periods of hundreds of days. It is expected to explode as a supernova sometime in the next 100,000 years. When it does, it will be a spectacular sight in our sky. We are watching a giant star in its final turbulent moments. Some stars rotate so quickly that they flatten into an oval shape. A star is a balance between the inward pull of gravity and the outward push of pressure and rotation. If a star spins very rapidly, the centrifugal force at its equator can partially counteract gravity, causing the star to bulge out. The star Vega, one of the brightest in our summer sky, is an example of this. It spins so fast that it is significantly flattened, with its equatorial diameter being much larger than its polar diameter. It is a sphere that has been shaped by its own incredible speed. A star cluster is a group of stars that all formed from the same giant cloud of gas. Sometimes a nebula is so large that it doesn't just form one or two stars, but hundreds or even thousands of them at roughly the same time. These stars remain loosely bound together by gravity for a time, traveling together through the galaxy as a star cluster. Because they all have the same age and composition, they are perfect natural laboratories for astronomers to study how stars evolve. They are families of stars born together from the same cosmic cloud. Some of these clusters are ancient, containing the first stars of a galaxy. There are two main types of clusters. Open clusters are younger and more loosely bound, typically found in the disk of the galaxy. Globular clusters, on the other hand, are ancient, tightly packed spheres of hundreds of thousands of stars. They orbit in the halo of our galaxy and contain some of the very oldest stars in the universe. They are like ancient, glittering cities, relics from the galaxy's formation. The space between stars is not completely empty, but filled with a thin interstellar medium. While we often call space a vacuum, it is not a perfect one. The interstellar medium is a very diffuse mixture of gas, mostly hydrogen and helium, and tiny particles of dust. On average, there is only about 1 atom per cubic centimeter of space. But because space is so vast, this thin material adds up. It is from this medium that new stars are born, and it is into this medium that old stars return their elements. It is the fertile, empty sea of the galaxy. Our Sun is currently passing through a region called the local interstellar cloud. Our solar system is not in a void, but is moving through a small, wispy cloud of interstellar gas. We entered this cloud a few thousand years ago and will exit it in another 10 to 20,000 years. The Sun's heliosphere, the bubble created by the solar wind, protects us from this interstellar material, pushing it back and shielding the planets. We are journeying through a faint, invisible fog on our path around the galaxy. There is a star named 55 Cancri E, whose planet is believed to be made of diamond. This exoplanet orbits its star so closely that its year is less than one Earth day long. It is a super-Earth, a rocky planet much more massive than our own. Based on its density and the composition of its star, scientists have theorized that this planet's interior could be carbon-rich, and the immense pressure could have formed a thick layer of diamond. It is a world that adds to the incredible diversity of planets we are discovering throughout the galaxy. Most of the stars that have ever existed are still shining today. This is because the most common type of star, the red dwarf, has a lifespan that is hundreds of times longer than the current age of the universe. The massive, bright stars that live short lives are relatively rare. The vast, silent majority of stars are these slow-burning, enduring embers. The universe is still very young, and its stellar story has only just begun. The great age of fading will not come for trillions of years. The light of a star can tell us what elements it is made of. When starlight is passed through a prism, it splits into a rainbow or a spectrum. But this spectrum is not perfectly smooth. It is crossed by dark lines. Each element, when heated, absorbs light at specific, characteristic wavelengths. By looking at the pattern of these dark lines in a star's spectrum, astronomers can determine exactly which elements are present in the star's atmosphere and in what quantities. A star's light is its fingerprint, revealing its chemical soul across the void. The quiet hum of a star is the sound of creation itself. While we cannot hear it, every star is a place of constant, gentle creation. In its core, new elements are being forged, the very building blocks of future planets and future life. The light and warmth it radiates is the energy that makes existence possible.
A star is not just a thing.
It is a process. It is the universe in the act of building itself, of turning the simple into the complex. It is a quiet, steady engine of cosmic becoming. Every star is a gentle, gravitational anchor in the vastness of space. Each star creates its own small island of stability in the cosmos. Its gravity gathers worlds, shepherds asteroids, and defines a small, orderly system around it. The universe is not a featureless void, but is punctuated by these millions of points of influence, each one a center of gravity, a potential home. They are the anchors that give the universe its structure and its peace. The silent light of the stars is a constant, soothing presence in the universe. No matter where you are in the cosmos, you are bathed in the gentle, ancient light of distant stars. It is a light that has traveled for eons, a light that asks for nothing, a light that is a silent testament to the vastness and the endurance of the universe. It is a reminder that even in the deepest darkness there is always light. It is the universe's oldest and most peaceful lullaby, and so our gentle drift through the starlight comes to a close. Our journey through the endless sky draws to an end for tonight. The vast, silent ocean of space recedes, leaving only the quiet comfort of your own room, the feeling of stillness, the gentle rhythm of your own breath. We have wandered through fields of newborn stars and listened to the whispers of ancient, dying suns. We have felt the immense scale of the cosmos, not in numbers, but in the peaceful feeling of its endless expanse. We've touched upon the simple truth that the colors of the stars are their temperatures, and that their